Hello guys, let us continue our discussion of this JEE Advance 2025 sample paper. So the question number 3 next we discuss this thing. We have an ellipse here. F1 F2 are two foci. P is the point on the circumference and that is neither on the major axis nor the minor axis. Let PF1 intersect the ellipse again at Q point, PF2 intersect the ellipse again at R point. Then we have to see about these options now. Option A says the perimeters of triangle PF1R and PF2 are not equal. So this is a single character problem. So we have to see which of the following statements is true. So first we see PF1R for this triangle and PF2Q for this triangle. We have to see their perimeters. If I see perimeter of PF1R, it will be PF1 PR plus RF1. You see this PR we can break as PF1 plus RF2. So you get PF1 plus PF2 plus RF2 plus RF1. Now if you see PF1 plus PF2 will be 2A. That is the definition of ellipse. The sum of distances from any point of any point from the foci is equal to length of major axis. So PF1 plus PF2 will be 2A, RF1 plus RF2 will be 2A. So you get total 4A. And if you see for PF2Q, same thing will happen there also. Will come out to be PF1 plus PF2, QF1 plus QF2. So that also will be 4A. So their perimeters are equal. Now from here itself, you see the C option is saying the perimeters of triangle are bisected by F1, F2. Now if you see this triangle PF1R, this is the line F1, F2. You will see the length of the sides on top of F1, F2 will be PF2 plus PF1, which will be 2A. On bottom of F1, F2 will be RF1 plus RF2, which will also be 2A. So you can see this side, like this line F1, F2, bisect this triangle into two parts of equal perimeter. So we see the sides of triangle only. So PF1 plus PF2 is 2A, RF1 plus RF2 is 2A. So both sides are equal. So we say this is C option is correct. So there is no need to check any other option. Directly you can say option C will be correct. Let us go to the next problem, guys. Question number C. This saying sixth problem. This saying V1, V2 be two distinct non-zero vectors, and we define a sequence of vectors as follow. Vn plus 2 is Vn cross Vn plus 1 for n greater than equal to 1. S is a set of vectors in Vn, and T will be set of unit vectors of Vn. So whichever vector you have here, we find their unit vector and make a new set T. And this saying that if a vector in V is a zero vector, then you see zero vector we can't find its unit vector, so those vector will exclude from T. Now we have to comment upon n of s. You know, n of s means the number of elements in S. We're saying there exist vectors v1 and v2 for which n of s will be 2. So v1, v2 are two distinct non-zero vectors. So already we have two elements in set S. We're saying there should be exactly two elements only. How will that be possible? That will only be possible if v1 cross v2 will give you v1 or v2. Because otherwise we get a third new vector. Even if we take v1 and v2 are collinear, then we get zero vector, which is also be a new vector. So can't have a third new vector here. We want number of elements to be 2 only. Otherwise we cross them and we get v1 or v2. That is also not possible, because if we cross v1 and v2 we get a vector which is perpendicular to their plane. So statement A has to be false. When you cross them, you will surely get a new third vector. Now, there exists two vector v1, v2 for which n of s is equal to 3. This is very easy. You can take an orthogonal triad like ijk. So if I take v1 as I, v2 as j, when you cross I and j, we get k. Then you cross j and k, we get I. Then you cross k and I, we get j. So every time you get I or j or k, so in S we'll have only three elements, which is true then. Next, there exists v1, v2 for which n of s is 4. Now you have to see that in the previous example, we have seen that if you get I and j, after that you get a triad. So if you get I and j, like any two of these vector, then third vector will keep on repeating from the same. That means if I take two vectors as say j and k, and the first vector should be such that if I cross with j, we get k. But it should not be I, because if I take I as the first vector, then you get three vectors only. So I want a vector, first vector to be not I, second vector we can take j, third vector should be k. Because if second vector j, third vector k, fourth vector will be I. So the first vector should not be I. You have to think of a vector which you cross with j, we get k. What you can take here, any vector of this like this. If I take I plus j as a first vector, so when you cross with j, you get k only. So after that, if you get j and k, then next will be I, then next will be j, and so on. So I plus j if I take first vector, then second vector could be just j, third will be k, and then you get I. So we'll have four vectors now. And the last one, saying if for some v1 and v2 set S is infinite, there are infinite vectors in set S, then T is also infinite. Now this will be false, because if I take say first vector as I cap, second as 2j cap, then third vector will become 2k cap, fourth will become 4i cap, fifth will become 8j cap, so it will be increasing. Magnitude will be increasing. So in S we'll get infinite vectors, but in T we get only, if you take the unit vector, that will be either I, J or K. So even though S has infinite vector, T has only three vectors. So statement D will be false. So the answer will just be B and C. Okay guys, next problem. In the seventh one, we have the saying a function complex number to complex number h of z is eta times z, then which of the following statements are true? First of all, you see when you do h z equal to eta z, multiplying a complex number with eta rotates it by 90 degree in anti-clockwise direction, keeping the modulus same. If you multiply a complex number with eta, geometrically it rotates the complex number by 90 degree, keeping the modulus same. So the option A, they are saying H maps the unit circle with itself only. You see, x square plus y square equal to 1. If a complex number x plus eta y lie on this circle, let us say this is a unit circle, and P1 is a point which lie on that, and if I use this function eta z on P1, it will rotate by 90 degree, keeping the modulus same. That means it will, if modulus is same, see, initially modulus is 1, and after rotation also modulus will be 1. So the point after rotation also will lie on the same circle. So every point on the circle will get rotated by 90 degree in anti-clockwise direction, but they all will lie on the circle itself, so it will be true. Next, H maps complex upper half plane. See, what is this upper half plane? A complex number x plus eta y where y is positive. That means if you take this on Argand plane, y positive means the complex number will lie in first or second quadrant. So it's saying H will map any point from H to H only. That means if you take in a point in first or second quadrant, if you use this function H on that, it will still lie in first or second quadrant. You can see clearly it will be wrong, If you take point in second quadrant and H will rotate it 90 degree, so the point will now come in third quadrant. So this has to be false. Next, H maps the unit circle centered at 0 to itself. Let us just take a unit circle. This should be 1 by 2. X equal to 1 by 2 minus 1 by 2. Y is 1 by 2. Here minus 1 by 2. A unit square, side length will be 1. So if I take a point on this, let us say this P1 I take here. So the P1 point will become x comma 1 by 2, and x will lie between minus 1 by 2 to 1 by 2. So the point will become x plus iota by 2. Now if you multiply with iota, we get x plus iota by 2. If you multiply with iota, we get minus 1 by 2 plus iota x. You see the coordinates of the point will become minus 1 by 2 comma x. And you can see minus 1 by 2, that means it will lie on this line. X is the y coordinate, which will lie between minus half and half. So the point after rotation will come on this line. So it will still lie on the square itself. So this statement will also be true. Next, D option. You say h of h. So the composite function h of h maps a straight line passing through origin to that line only. See, a straight line passing through origin will be y equal to mx. So z, if you take, here will become x plus iota y, y will be mx. If you take h of z on this, so h of z will make it multiply with iota, will make it iota x minus mx. And when you again multiply iota here, you get minus x minus iota mx. So the point will now become minus x comma minus mx, which will still lie on the same line. That means h of z will map every point on the line to the line itself. And right now I'm taking y equal to mx. You can take even x-axis or y-axis. X-axis will mean every point will be purely real. So for every point purely real, when you multiply with iota, it will become purely imaginary. And again you multiply iota, it will again become purely real. So same line. And same thing will happen for every point on y-axis also. So this statement will be true. Next one, guys. Eighth one. In the eighth problem, they're simply saying to find aij, you differentiate x bar m I times and put x equal to 1. Divide by differentiate y bar n I j times and put y equal to 1. So if you have to find a11, you differentiate it one time, so you get m x bar m minus 1 by n y bar n minus 1. Then you put x and y as 1, you get m by n. Okay, to find a1 comma 2, so in numerator will be m, so this x bar m you differentiate one time, the denominator differentiate two times. So this is same pattern we keep on going. So m by n into n minus 1, then 3 time differentiation in the denominator, finally get m by n factorial. If you do a2 comma 1, so in the numerator we differentiate twice, denominator will be one time. So you get m into m minus 1 by n, and in the first column the denominator will be same and the numerator will keep on increasing, last will be m factorial. Same here, 2 will be differentiate 2 time 2n will be differentiate 2 time n time. Here n2 will be differentiate numerator n time, denominator 2 time, and last differentiate m time n time. So this is your matrices A. Now what are they saying now? Pi is maximum of aij when j goes from 1 to n. So basically means in the ith row we are finding the maximum element. We're finding the maximum element of ith row because I is fixed, j is moving. So P1 will be maximum element of first row. You can see maximum element of first row will be the first element only because denominator is increasing this side. So P1 is m by n. Similarly, P2, maximum element will be first element only. And then they're saying P. P is the minimum of all the PIs. Minimum of all the PIs. So P1, P2, P3, all that we have got. Now we have to find minimum of them. You see P1, in each row, the maximum element was first element only. That means now in the first column, we are looking for the least element. You can see the least element of first column is the first element only. Because denominator is same and numerator is increasing when you go down. So least element is m by n. So P is m by n. In Q, they're asking the minimum element of Aij when I goes from 1 to m. That means they're asking for the minimum element of jth column. So if you take first column, least element is m by n. Second column, least element is m by n minus 1. M by n into n minus 1. And for the last column, least element will be again m by n factorial. And now Q is the maximum of all of them now. Whatever Qi value you have got, Qj values we have got, now you have to find maximum of all of them. You see minimum of each column was first element only. So now we're looking for the maximum element of first row. Maximum element of first row is again m by n. So P is m by n, Q is also m by n. In the first option, they're asking P greater than Q, which will be false. So option A is false. Next. In option B, they're asking that A11 is less than A22 less than A33 up to ANN if M is more than N. So A11 you see is M by N. A22 you see is M by N into M minus 1 by N minus 1. M by N into M minus 1 into by N minus 1. You see if M is more than N, M minus 1 by N minus 1 will also, like M minus 1 will also be more than N minus 1. So if numerator is more than denominator, this value will be more than 1. So we are multiplying m by n into some number which is more than 1. So A22 will be more than A11. And same thing will keep on going on. So we can say option B will be true. Next. Next they're saying am comma n is equal to am minus 1 comma n minus 1. So basically this is the last element. They're looking for this and this element. Then again previous this element. So see what will happen is in am comma n we differentiate m times n times. In am minus 1 comma n minus 1 you will differentiate the previous, this term will be differentiated m minus 1 time. So rather than having m factorial will not have like last term. Basically we're coming in this order, no, m minus 1 up to 2 into 1. So this last term will not be there. So I'll just say it is m factorial by 1. Divide by n factorial by 1. Here also the last differentiation will not do, like 1 x bar in the numerator x bar 1 will be left, in denominator y bar 1 will be left. We are differentiating m minus 1 time and n minus 1 time. So this value will be n factorial by 1. So this by 1 get cancelled out to get m factorial by n factorial. In am minus 2 comma n minus 2 will differentiate m minus 2 times. So last two terms will be not there from the m factorial. So it will be m factorial divided by 1 into 2 divided by n factorial divided by 1 into 2. Again this and this will get cancelled out. M factorial by n factorial. So you can see all of them are same as m factorial by n factorial. So the statement will be true. And last, if asymmetric matrices if m is equal to n. See if m is equal to n, if you just focus on these two elements, this m by n get cancelled out. But here you get 1 by n minus 1, but here we get m minus 1. Obviously, they will not be equal. So it cannot be symmetric matrices. So this will be false. I hope it makes sense, guys. So answer here will be B and C only. Next. Now this is ninth problem. Very interesting one. F of x is given 3x plus 4 cos x. G of x is given 6 pi x minus 1 whole square. We have to find this thing domain is 0 to 2. We have to find number of local maxima, number of local minima of f of gx. So in the domain 0 to 2, we have to find number of local maxima, number of local minimas of f of gx. So find f of gx will be 3gx plus 4 cos g of x. You see here, this is f of x, this is g of x. So f of gx will be 3gx plus 4 cos gx. Then differentiate with respect to x. You get 3g dash x minus 4 sin gx, g dash x. Chain rule. G dash x common here, you get g dash x into 3 minus 4 sin g of x. Now g dash x you can find from here will be 12 pi x minus 1, and sine of gx will become 3 minus 4 sine 6 pi x minus 1 whole square. Now, how do we find for maxima minima? We can just directly use wavy curve method on this thing. See how? X minus 1, see it will change sign with respect to 1. If you put number more than 1, it will be positive, less than 1, it will be negative. X is from 0 to 2. So 0 to 1 will be negative, 1 to 2 will be positive. Let us talk about this. 3 minus 4 sine 6 pi x minus 1 whole square. See, when I put x as 0, this will become 6 pi. When I put 1, it will become 0. So the value inside sine is going from 6 pi to 0 in this direction. Now, this thing will be 0 when sine theta will be 3 over 4. So I plot the graph of sine x from 0 to 6 pi and draw a line y equal to 3 over 4. Mark the points wherever it intersect alpha 1, alpha 2, alpha 3, alpha 4, alpha 5, alpha 6. And like we see here, this will be 0 when sine theta is 3 over 4. When sine will be more than that, it will be negative. This value will be negative. And when sine is less than that, this value will be positive. Okay, so you put sine, if you put x as 0, it becomes 6 pi. At 1, it is 0. So when you put x from 0 to 1, it goes into this direction. So let us see now what will happen here. So from 0 to 1, like we discussed, this outside thing is negative. So whatever sign will be here, we have to invert that. You see from 6 pi to alpha 1. So these points basically will be alpha 1, alpha 2. I have plotted them from 0 to 1. Because when you put x from 0 to 1, it goes from 6 pi to 0, sine thing. So alpha 1, alpha 2, alpha 3, alpha 4, alpha 5, alpha 6. So first of all, you put 0, you get 6 pi. So 0 to alpha 1, the value of this thing is positive. It's, below the line graph. But this value is negative, so positive into negative will become negative. So between 0 alpha 1, it is negative. And after that will be alternate sign. Between alpha 1 and alpha 2, this is above the line, so it will be negative. So negative, negative become positive. So just minus, plus, minus, plus, minus, plus, minus. So we reach here. Okay, so for 0 we were here, at 1 we reach here. When x is 0 and 1. Now this thing will change sign. So now when you put 1 to 2, so now at 1 this value is 0. At 2 this value will become 6 pi again. So when you put 1 to 2, now we go in this direction. So I'll put all the roots here again. So alpha 6, alpha 5, alpha 4, alpha 3, alpha 2, alpha 1. So now between 1 and alpha 6, this value is below the line, so it will be positive, and this also outside is positive. So 1 to alpha 6, it is positive. And after that again alternate sign, plus, minus, plus, minus, plus, minus, plus. This is wavy curve on the differentiation of the function. And the sign here will give the nature of the curve. So 0 to alpha 1 negative means graph is decreasing. So 0 to alpha 1 decreasing, alpha 1 to alpha 2 increasing, then decreasing, increasing, decreasing, increasing, and keep on doing that. Now, how many minimas you see? 1, 2, 3, 4, 5, 6, 7. So n will be 7. How many maximas you see here? 1, 2, 3, 4, 5, 6. So maximas are 6. So finally they're asking the value of 2m plus 3n, which will become 33. I hope it is clear, guys. Next. On the next problem, we have in is 0 to infinity 1 by e power x plus e power minus x whole power n dx. F of p comma q is 0 to 1 x power p minus 1 minus x power q minus 1 dx. Saying I22 is f of alpha comma beta by gamma, where alpha, beta, gamma are natural number. Find this value. So what do we do here? I22 will just become 0 to infinity dx by e power x plus e power minus x whole raised to power 22. I write e power x as 1 by e power minus x and take LCM. Write e power x as 1 by e power minus x and take LCM. We get e power minus 22x dx by 1 plus e power minus 2x whole power 22. Now we'll do very smart substitution here. I'll take this thing directly as 1 minus e power minus 2x by 1 plus e power minus 2x as t. You see here both the terms are in the numerator. So I want this 1 by e power minus 2x in the numerator only. So I wrote this in the denominator. And how do we decide the numerator? I wanted the limits also to go from 0 to 1. So here if I put x as 0, you get 0 only. And when we put x as infinity, we get 1. So it will serve both the purpose. It will change the limit 0 to 1 and the terms from the denominator also will come in the numerator. See how? Here if you add 1 subtract 1 you get minus 1 plus 2 by 1 plus e power minus 2x t is equal to t. So from here you get 1 by 1 plus e power minus 2x will be t plus 1 over 2. So the thing in the denominator will come in the numerator. Now to convert dx in the numerator, we can just find e power minus 2x in term of t from here. You get e power minus 2x, 1 minus t by 1 plus t. And we can again add 1 subtract 1, you get minus 1 plus 2 by 1 minus t. Now differentiate with respect to x, you get e power minus 2x minus 2 dx equal to minus 2 by 1 minus t whole square dt. So minus 2 will get cancelled out. Now, like we discussed, limits will change from 0 to 1. This e power minus 2x dx. So e power minus 2x dx will be used. E power minus 20x will be left. And e power minus 20x we can write as power 10 of this. So it will become 1 minus t by 1 plus t power 10. Next, this 1 by 1 plus e power minus 2x, we can write as t plus 1 by 2, so it will become t plus 1 by 2 power 22. And that e power minus 2x dx will become from here dt by 1 minus t whole square. So when you simplify, you finally get this thing only. You get 1 by 2 power 22, 0 to 1, 1 minus t power 10, 1 plus t power 10 dt. Now to convert it to the given form, I'll just do some rearrangement here. Use king rule. We get t power 10, 2 minus t power 10 dt. Now put t as 2x. When you put t as 2x, it will become 1, this outside as it is. The limit will become 0 to half. It will become 2x power 10, 2 minus 2x power 10, 2x, 2 dx. Here 2 will be common out. You get 1 by 2 of 0 to 1 by 2 x power 10, 1 minus x power 10 dx. Now we know that property f of 2a minus x equal to f of x. So we can break the limit like 2 times 0 to a. So we are doing that in the reverse order here. So here limit is 0 to half. I'm making it double because the function will satisfy that thing. F of 1 minus x will be f of x only. So usually if you go this direction, we multiply by 2. Here I'll divide by 2. So you get 1 by 4, 0 to 1, x power 10, 1 minus x power 10 dx. So if you compare now, this is nothing but 1 by 4, 4 outside. This will become f of 11 comma 11. So alpha will be 11, beta will be 11, gamma will be 4. So you get 88 as the answer. Okay, this was a good problem.